Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about LPCAMM2 or low power consumption compression attachment memory modules. So let's dive deep into it. So what exactly is the problem? Well, problem is that RAM is very power hungry and very big. Now, what does that mean? That simply means world has moved into a different location where we want slim and efficient. Not only it has to be physically low profile, quote unquote, but it also has to be efficient. Meaning we are no longer in the era of where laptops only have lifespan of 1 hour or 2 hours. We want laptops that had 8 or even 9 hours, even on Windows. So we need a different strategy, so to say. Now, on top of that, this structure of RAM that you are used to, this puppy is 25 years old. Now, it is reaching its physical upper limitation, meaning can we increase the signal strength? Yes, but that will come at a consequence of very high power draw, meaning we have maxed it out. Can we try to push it? Maybe, but output is like this is so painful to solve at this point in time in terms of clock speed, in terms of latency, in terms of all other stuff, that it's literally creating a scenario where soldering RAM is far more efficient. Now, why soldering RAM is efficient? Again, the longer your signal path is from processor to the RAM memory chip, the more energy it needs to transmit that long. Again, longer transmission, more energy you require. Now, problem is that normal RAM chips that you use, DDR, that's a really powerful puppy, very efficient, very high performance, but that does not sleep quite well. Now, whenever you talk about LP, DDR, LP is a specific product pipeline, so to say, that's designed with one thing in mind, meaning it shut down very effectively. Now, RAM has to stay on in order to store the data. It basically is not a passive material. It's not like hard drive or SSD. So it must consume energy in order to maintain the state. But LPs are designed in such a way that it does not consume a lot of power, meaning instead of consuming, let's say, a watt, it's consuming 1/10 of a watt while it's a standby. And that's why when Apple started to use this sort of soldering system, they jumped to LP RAM very quickly, and because of the trace length was smaller, and again LP does not have the signal oomph where it can go from from chips here to the actual processor. This actually saved them a lot of energy advantage, and that's why all other companies are moving. It's not about making more e-waste. It's not about limiting consumer choice. There is a genuine reason for it. We have reached the upper limit of this genuine reason. Like, this simply reached a point where DDR5 is not even flying fully. Like, at this point in time, you can buy from same manufacturer base, be it Asus, be it Dell, where they are giving you two options, like DDR5 this, DDR5 this. DDR5 that is soldered would be higher frequency, lower energy consumption compared to DDR5 that is slotted. So we reached the upper limit of sodium form factor. Like, there is a physical, like law of physics kind of travel distance here. We can't do much about it. Like, it has reached a physical limitation. Can we solve it? Of course. Can we solve it while remaining energy efficient? No. It's like, I want to fly faster. It's like, yeah, you can do that. It's going to take more fuel. I want to carry more payload. Yeah, of course you can do that, but it will consume more fuel. So same thing goes here. Soldering RAM is a solution, but now you may be like, doesn't that make company very happy? Other than Apple, no. Actually, no other company wants to do this, because it has consequences for both parties, not only for you and I, consumer, but also for producers. Why? Well, imagine it this way. Let's say you are Apple-like company, and you are like, okay, our laptops are expensive. We want to have very high profit margin. But if you had something very high profit margin, and the first product in your lineup is, people will like, they won't even try it. You want people to get addicted into your system. So you want to have a low cost variant, like how Samsung has like 3 to 4 RAM variants on a mobile phone. So you are like, okay, this is very expensive laptop, but it has only 8 GB of RAM. Now, back in the ancient times, that wasn't a problem. People bought those sort of systems. If they were happy with it, they were happy with it. If they were unhappy with it, they're like, hey, you know what, more RAMs will solve my issue. Voila, you could solve it. Now you cannot do that, meaning while you are buying a device that has solder system, you have to make a decision, and you have to just bite the bullet. You have to like, okay, what's the highest I can afford at this point in time? If you're like, hey, I can only afford 32 GB, you better be happy with 32 GB for the rest of the life of the device. Otherwise, you're stuck. Now, back in the old days, you could literally have a system where it's like, hey, I bought a 16 GB system, but after using for 3 years, 64 GB kits are quite cheap. So we went from a system where laptops are used much longer to be basically better locked. You are locked. You're locked. Basically, you have to make right decision on day one, which basically means you have to overpay as much as you can. So you lose your choice. So that's the consumer part. People know it. And again, failure, maintenance, and all that, that's another issue. So doesn't that make it awesome business deal from a corporation's point of view? Actually, no. It's like, why? Well, here's the deal. They are also stuck, meaning they have to front load their investments, meaning they will create, okay, this is the processor, it's not going to change. Awesome. We have laptop. Awesome. Laptop has 3 SKUs. Yeah, this is where it sucks. So they cannot use, like back in the old day, they will literally have one module placed in. And if you're like, hey, that module is not selling enough, no problem. Same factory, they'll like, hey, place another DIMM. To me. Problem solved, no problem. And again, if like we want more RAM, remove both of them, put a new RAM. Nothing fancy, nothing hard to do. Here it's like they have to take a gamble. It's like Apple. How many dumb people are there that can be expected to buy 8 GB? Be mindful, my mobile phone has higher RAM than that. It's like how many people will buy this? Now they have to front load their investment. They're like, okay, we're gonna produce 1 million of 8 GB, we're gonna produce 2 million of 16 GB, and we're gonna produce 1 million of 32. But turns out a lot of people are buying 32. Nobody's buying it. Yeah, you're stuck. You cannot just like, okay, we're gonna take it, disassemble it, desolder these things, and these things are not designed to be soldered and resoldered again and again. Again, you can do that. It's not designed to, and there is a reason why. Whenever you have RAM failure in this sort of system, they just eat the whole board to replace a new board. So it's painful for consumer also, meaning product SKUs get locked for both of us. Like for my side is also locked, for consumer, for producer also it's locked. It's like I have to just roll the dice and hope that my guess is correct, or just have one option. So they do not like that. So there is a genuine problem. This structure was awesome, but it can only take us so far. It's like, it's nice while it lasted, but it's reaching its age, 25 years, man. So we need to have a way where we can shrink the distance. So we can use low power RAM, and even if you have high power RAM, you can increase the frequency. So you have more power budget, rather than you wasting the power budget on just sending signal far. You're like sending signal fast. So this is the genuine problem. So let's understand the Mark 1 product of this. Dell actually started this new pathway, which is genuinely shocking given their recent track records, but they actually tried it. They're like, hey, what if we actually solve it rather than just like soldering it? Or maybe they had like few engineers laying around. So they actually did that, and it actually worked. What they figured out is like, what is the only connector in your motherboard that is the highest speed? You're like, right, is the processor. How many pins those puppies have? Bonkersly large amount of pin count, 1,000, 2,000. Go into server, they're like 4,000 pins, man. So it's like, okay, we got the pin problem. So what if we use that architecture of land grid array into RAMs? Voila. And it's like, hey, wouldn't that make the slot very expensive? What if we make that into replaceable parts? So your motherboard is just a normal PCB. Your RAM module is just a PCB. How do you connect it? You just have a physical plastic holder that contains all the copper blocks, and then you have a block from the backside that is providing the compression. Exactly like how you have latch in your motherboard for your processor, same thing. Simple, elegant, works. So they figured it out. Now, why is this? Well, here's the deal. When you are talking about RAM chips, they are way too time sensitive, meaning this puppy's signal timing to the RAM processor has to be exactly the same as this. And you're like, hey, we know electrons do not move at light speed. So fundamentally, there will be latency from here to there. Now, was that an issue back in the old days? No, it was not fast enough. Now it is fast enough where they're like, yeah, we have to match it. So what do we do? So if you had the normal slot system, you had to have a serpentine trace, as we call it. That trace is basically making sure that this has unnecessarily long trace, so it matches this one. So every single trace is matched. But if you have this sort of pathway, now it's much easier to trace match, exponentially easier. That's how we can make processors in the first place. That's how you can have a processor that is used in servers that are 4,000 pins. How is that even possible? Because of this grid array design rather than having slot. So they're like, okay, we got the PCB idea. We know how to manufacture PCB. This is literally the PCB, basically desolder the processor on the PCB of the laptop motherboard, you'll find the exact same thing. So we know how to do this. The guard sorted. We know how to make this, and we simplify our job of basically trace layout engineers. It's like, hey, we have a lot of option. Take your time. Now they reduce the distance from 7 centimeters to 4 centimeters. Like, is that a big deal? That's shut up, take money kind of big deal. Like they must have good engineers, like really good engineers who actually figured this out. And here's the interesting part. The cost increase, even when they are the only company doing it, is marginal. It's like they literally work their ass off to make sure that it's not expensive to make. Fundamentally, it's not that expensive to make. So they did that, and they launched a whole product lineup. Now be mindful, because this was a new system, and again, you have to be willing to take some serious risk. It was only available for latitude lineups, as in like pro level lineups. They did it. However, this created a problem for Dell itself. Is like, if you are talking about memory chips, they are very agnostic. It does not matter you're buying from Samsung, it does not matter you're buying SK Hynix, Micron, whatever have you. They are very agnostic. The footprint is once finalized, done. But here's the deal, what about this module? So any company that is fabricating the module can charge whatever the hell they want to charge to Dell, because where else would you go? So Dell, actually realizing that they have developed actually something good, they wanted other companies to use it. JDAC. Now here's the deal. If more companies use this, more competition will be available for this. More manufacturers will be available for this. That will keep the cost low. So it's actually in your everyone's interest. Now be mindful, this is common thing done in basically computer industry. Basically, when you're talking about ATX, what does that mean? It's an Intel specification which AMD can follow, Apple can follow, every other manufacturer can follow. So same goes here. JDAC is the association that is responsible for all of that. What is JDAC? JDAC is Joint Electronic Device Engineering Council. If you want to simplify, think in this way. How do we know Bluetooth works? Because there is an association known as Bluetooth Association. They make sure of that. How does USB work? There is an association that maintains it. Same is JDAC is responsible for RAMs. So Dell went to JDAC and it's like, bro, let's try to redesign the SODIMM architecture. And you're like, didn't SODIMM change? All SODIMM was changing was like physical pin count and the notch. So it does not interfere. But the physical structure, the layout, the principles, all of them did not change. So this was the first time in 25 years somebody was like, what if we try something different? So this was Mark 1. It does work. It's real. You can buy it. And Dell showed surprisingly for, very good hindsight. It's like, hey, our engineers made something good. What if we use it? What if everybody benefits from it? So they went to JDAC to make it open, because without JDAC stamp, it's a Dell proprietary stuff. This was Mark 1 product 1 year ago. So now we come to LP, low power compression attachment memory module 2. This is a Mark 2 product. Now this was standardization was done by JDAC. So now it's a real thing, meaning now all companies, be it Samsung, be it Micron, be it whatever, be whoever, all of them can now trust this. This is here, this is real, this is not some proprietary that can be pulled out of their, below their feet. So it's absolute real thing. It's as real as SODIMM. So is there. Now, what is the core difference between version 1 and version 2? Version 1 was CAMM. It only supported DDR5. Now, be mindful, DDR and LP DDR is the same thing. The LP means it's a low power module and it can go into very low power standby. So, laptop that was used by Latitude, it was not very efficient, but it was efficient comparatively because trace length was smaller. So, it was good, but it was not very, very good in terms of efficiency. So, JDAC was like, hey, you got 80% there, let's take the 20% more. So now they have multiple options. So in CAMM2 you have support for DDR5 and LP DDR5, plus you have boatload of option inside that, which I do not know whether it's a good thing or bad thing. So you have a lot of options. So first selection, you go into, I need to worry about CAMM2. Okay, CAMM2, you have two choice. Choice number 1 for low power memories, generally used for handhelds, laptops, tablet, maybe this sort of thing. Okay, this is one very low power, very cheap unit. Cheap as in like compared to soldering. So this is one option. Second option is big, beefier, high power one, which is like basically Dell made this and JDAC took this, modified it, made it into this. And yes, electrically they are same, they have to be. So motherboard layout can be designed in such a way that it can support this or switch into this. You do not want like actual wiring to change again and again. So two options you will select. It's like, do I want high power or low power? Okay, once you select it. Now in low power, I have seen only one selection. It's like, this is it, done, go home. Okay, awesome. However, when you talk about high power, as in DDR5, they kind of got carried away. They have way too many options. They have option basically A, which is 40mm wide. Then you have option B, which is 68mm wide. Then they have option C, which is again is 40mm wide. And then they have option D, which is again 57mm wide. I have no idea why. Like genuinely, I'm like genuinely, if any of you know, it's like they are trying to add way too many variation, which in history says us that it backfires. So I do not know why they have so much, but they must have a good reason for it. I hope so. But for laptop it's clear, just buy this, forget about everything else. And how can you easily tell which one it is? Where is the hole? If you have 3 holes like this, like in a triangles formation, that's generally made for basically high power DDR. And if you have a straight line, that's generally made for what we call low power system. So that's what they are. And again, JDEC is still working on it. Basically their idea is, we got this is ready to use, ready to ship, but we have to upgrade to, in order to eliminate screws. You do not want a corporate mass production to rely on screws. People do not like screws anymore, so you want to make sure that you do not need to screw it. That's their future production pipeline, where it's like, that's what they are working on right now. So this is LPCAMM2. It supports both DDR for high performance application and LPDDR for energy efficient application. And in for like heavy workload, you have lot of choices, like way too much choices. You have choices. Now, what about implementation? That's just a paper and stuff. Is there any implementation? Yes, Dell was the first that actually released it, actually had something. And Lenovo ThinkPad is the first company. Lenovo ThinkPad P1 Gen 7 is the first physical product that has the standard version of it, not Dell proprietary, standard version of it. Meaning there, you can buy this laptop and replace the RAM yourself. And yes, RAM is available. Meaning if you have boatload of money, you can buy that RAM right now. It's available just to buy, like, pay money, buy it. It's not proprietary or something like that. Crucial is the brand that is selling it. Basically Micron's sub brand that is selling it. Right now you can buy it. It's available. And in Computex 2024, which is basically CES of computers, few companies showed like almost working prototypes or future concepts where they're having something like this, where the motherboard will have that. And you're like, why this has so much empty space? Yeah, I told you that they have much bigger variant. So there you do not have the luxury of this, where you have multiple slots and you're like, hey, I put 1, I put 2, I put 4. There you just have 1. So that is a bit side effect, but you can still get bonkersly high. And the highest capacity so far specified for DDR5, it's a half terabyte, 1 plate, like that 1 plate is half terabyte. So that's available. And the companies were showing up to 64 GB sticks. So that's available. Now, because DDR5 is in half generation at this point in time, and be mindful, DDR takes quite a long time to replace. From DDR2 to DDR3 is almost 10 years. Same thing, 3 to 4, 10 years, 4 to 5, 10 years. 5 we are in right now, and 5 is not 10 years old. So as in like public use, not server and public use. So it still has some life left. And be mindful, a lot of people are getting into DDR5 right now, and many of them are getting through this. This is a defective system. I am doing RMA on it, and I have to pay a boatload of money for security, because again, they said like, we're gonna RMA it, no problem, but you have to send both of them. It's like, only this is defective. It's like, no, send both of them. And like, that will shut down my system for 2 weeks. Not acceptable. So I put a bonkers large amount of RMA. So that will be the side effect. You will have one point of failure. If your RAM fails, RAM fails. You do not have the luxury that I got at this point in time. It's like, removed one of the stick, hey, system boots again. That means this was defective. You won't get that luxury. But again, I do not see in DDR5 too much penetration. But if this penetrates enough, where people have enough momentum, enough interest, especially for laptops, because there is no other choice, if there is enough oomph on it, I can easily see that DDR6 comes only in that. Like how USB 4 only comes in USB-C connector, same can happen here. Whereas like, you can or you cannot choose for DDR5, you have this option or this option. For basically DDR6, they're like, okay, let's just bite the bullet and just go into this. So now, would we expect to see this in servers? No, that's my personal feeling, because A, it has way too many standards. B, servers require way too much. Like the biggest offering that they are offering is only half terabyte. I know servers that are 4 petabytes of RAM. Yes, like we have reached bonkers amount of RAM. You cannot stack it like that. It's not designed to be stacked. It's designed from laptop's point of view. It's not even desktop point of view. Although some people are saying that in desktop it would be awesome if we can put it on the backside. That would be really awesome. And again, it will improve the latency part, because again, the physical length is smaller. So latency should improve and power consumption should decrease. Or you can have same power consumption as basically these puppies and have more oomph out of it, more frequency. So implementation is here. It's not just a vaporware anymore. It's real, it's here, people are buying it, people are selling it. So things have made some serious significant improvement in last 1 year. So what can we expect in the future? Well, this is one of the things that makes me good. This makes me feel very happy because this is a good news. This is like a company like Framework. They're actually trying to be good. So I'm genuinely shocked that Dell actually thought of like something good, and JEDEC actually put their efforts behind it to actually make it even better. And I'm happy that all other companies are jumping into it. Be mindful. Crucial, you can just buy. Samsung has already introduced it, and again, I'm pretty sure you can buy it, but you have to place bulk order. I'm not that rich, but you can get it. And be mindful, in Computex, way too many companies had like, yeah, we have this, like take it and go, running computers. So, and again, this was another aspect of Dell's engineering. Dell was very clear on that, it's just a PCB, much more simplified. They wanted to make sure that it does not take like, quantum engineering and all that. It's like very simple PCB with memory chips on it. So, and moving towards repairable, long-lasting devices where you can just, like for example, in my computer, I just realized how little 16 GB is because of modern Chrome. Is that my second computer was 16 GB. This I started with 32, and after removing basically one RAM stick, it has dropped down to 16. Now I realize that I actually may need to upgrade it, and here's it. I have that choice. I can be like, hey, 32 GB. Once I saved up more, I can buy it. Again, I have 4 slots, so I can buy one package of this again, and voila, I have 64. Or maybe even future, like 3 years from now, or actually it's available right now, but I'm not that rich, where I can just buy 128 GB sticks. I can buy 2 of them. The motherboard's maximum support is 200 GB, and at that point, that CPU will not be bottlenecked. I can do heavy AI crunching on my CPU, and I have a GPU support. Be mindful, PCI Gen 5 GPU and my NVMe, so I can keep using the system for much longer. Doing the same thing on laptops is actually good for everybody. So it's a very good thing. We want less e-waste. If you like, again, now this will become e-waste, but again, I rather have this as a e-waste than whole desktop as a e-waste. It's like, would you take 100 gram of e-waste or 1 kilogram of e-waste? Thou shall take 100 grams of e-waste. So same there. And actual limit was on, like, it was like not like, oh, companies are just trying to F the customers. Look, there is a genuine reason why sodiums, like this architecture was just not good enough anymore. Like, we reached a point, it was not working, and they solved it, which made me very happy. It's like, okay, this is the problem, let's solve it. Let's just not apple it, let's solve it. They solved it. It was really good, and amazing thanks has to go to Dell, JEDEC, Micron, Lenovo, etc. Basically Samsung also. And apparently, I could be wrong, but XPG handheld is the first handheld that has this RAM. And this will be game changer. Be mindful, what is the biggest limitation of Steam Decks? What is the biggest limitation of Asus ROG? Same thing. While the GPU, onboard GPU is very powerful, it's very hungry. And you cannot, like, again, if you have to solder it, it's expensive. So if you have this, right now you can buy, let's say, only buy 16 gigabyte. But if they have not firmware locked it, they could be just like, hey, buy it right now, enjoy, have fun, and then 2 years from now, just upgrade more RAM. Because be mindful, that's equivalent to increasing the VRAM on your GPU. That's more than awesome. That's like, shut up, take money. So if this is true, because be mindful, I could not find anyone who has actually opened it and showed this module in here. So I cannot be damn sure, but likelihood of this happening is actually high. It makes sense. Like, it makes sense. Why go through, bulk ordering multiple PCBs when you're like, hey, order one PCB and we're gonna just like, buy off the, and again, if things happen where it's like, hey, we are not actually selling low variant as much, no problem. Upgrade RAM, no problem. So this is a really good development. And this is how it looks, a small module in a big ass PCB of a motherboard. So this was my presentation on compression attachment memory module Mark II. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.